Hello everyone, last video we've been witnessing the game between the 30 iterations versus the 20 iterations neural networks that has been trained to play the game of Go on the 5x5 board, and this time the next candidate has arrived. So we have the 40 iterations version that is going to be playing against the previous winner, the 30 iteration version. Right, so without further ado, let's actually get started. First 10 games will be played with the for the 40 iterations network. The new network is playing black, and black is represented as axis on the board, and the white stones are represented as zeros. So black is new network, old network is white. Let's have a look. And like it usually happens, for some known reason it plays better with white stones, no matter the version. We'll see, is this going to be the case this time? Okay, well, this is already something new. Okay, so it starts being tactical at some point, which is really interesting. We didn't see this before. Yeah. So, like all the previous versions, were suffering from the lack of tactics, like no instant captures if that's essential in terms of that's urgent to win the game. But in this, already in the first game, we see that the capture has been made instantly, and that was a very critical thing to have. Okay, crushing win so far. Yeah, it takes around 5 hours and 30 minutes to train 10 iterations on my laptop Acer Spy 3, which doesn't even have the GPU, just has the built-in one. So the training is done only using CPUs. Okay, playing in the sensor, I really like when the network plays in the sensor, because from the human perspective, that's the only place where you can play in order to win the 5x5 game. Yeah, and splits the opponent into two parts. Well, this is getting much stronger, way more interesting to watch. Yeah. So yeah, I've been training, and still I am training this network without GPUs, just the bare CPU. So it's not even some. So I have two cores and 1.1. So I have two cores, and each core 1.1 gigahertz. So it's quite beyond average, to say the least. Yeah, it takes time, but the result is really, really rewarding here. So, okay, so something goes wrong for black this time. Yeah, white is doing good job so far, surrounding black, but yeah, still black defense, still black. Oh, this, yeah, that was stupid. That was stupid, really. Yeah, and another instant capture. I don't care about whether it wins or loses, but this instant captures, yeah, still wins. Yeah, this instant captures, where it's absolutely essential, makes the current 40 iteration version much stronger. And you just bear in mind that I only play 10 games of a self play for every single iteration. So like 10 more iterations over the previous versions is like only 100 games played to get the training data. And that's not much, really, as opposed to the original AlphaGo experiment, where they have been playing millions of games and spent like millions of dollars for the hardware costs in terms of renting the hardware. So yeah, well, very listed according to Wikipedia. So yeah, it's really fun to watch how you can approach with a minimum. Oh, what have you done? What have you done? Just remove its own eye. Yeah, this is the mistake. This is the critical mistake. You see, so in this position, he should have captured instantly. and in that case, white plays here, and black captures the entire group. But it removes its very own eye, like here, played here. That's the critical mistake which costed the game. Yeah, unfortunately, that costed the game. Yeah. Oh, look at this beauty, guys. This cross here in the center is trying to split the board into two parts. Well, this is the strategy that the human player would come up with. That's the most natural thing to have. Yeah. So numerous Ataris, so tearing this one already, capturing. These stones are in danger. Okay, capturing these stones. Cool. Okay, and a fair win here as well. Although 5x5 board is like not really practical to play on, but it's so crushingly representative, I would say. Yeah, I love this move. I love this move. It's so representative in terms of like when you see human players, when you see human players playing on different board sizes than say like 9x9 and 13x13 and 19x19 are absolutely different styles. But the neural network doesn't really care much about the board size, and when it's training, eventually, obviously, it will come up with the human-like moves because that's the only way to win on the 5x5 board. But during the training process, it feels to me, it feels like it sort of plays like as if the board size was like maybe 19x19 even. So it's not trying always to play tactically, but it's trying to be very creative, trying to split opponents' groups, no matter the board size, tries to create ice. Well, sometimes it takes its own ice, and this costs the game result. But anyway, generally, it's really interesting that again you just can train the network on a very small board, but the results are still really, really exciting. Yeah. Okay, lost this one. Yeah, fair enough. Fair enough. So, for those of you who probably missed the original, maybe uh, video in the series, like the first video in the series, I've been mentioning that the major goal for this project, for me personally, is to see the relative improvement of the neural network over the iterations. So it's clearly seen that if you take, say, I don't know, Apache or Catago and play on 19x19 board, in that case, yeah, you are dealing with a done level engine, a very strong engine. But you don't have an idea, like, how did it play during the early stages of training? So when it was not as strong. So how did it play? That's really interesting to know. Well, at least to me. Okay, another Crush and Win, cool. Yeah, and with this experiment I'm running here, it's possible to see how the early stages of neural network training are actually what they look like. Oh, it's another idea here. So it didn't capture, but instead of capturing, it's just trying to tear another stone. But this costed it to like losing the stone. Although it tried to build the territory on top. Yeah, that's interesting. That's interesting. Yeah, maybe for even for like beginner human Go players, who just start with the game and just understands the rules of the game. Watching this training process of the neural network might also be quite, you know, resourceful and educative because, yeah, this is like, mm, I don't know, just to see what you should do, what you should not do. Yeah, it's a bit like tic tac toe in terms of the board size, but The game is way more complicated as opposed to tic tac toe. Yeah, even though the symbols being used to represent stones are the same as in tic tac toe. Okay, all right. Yeah, so black wins 6 times, so new network wins 6 times. And the old network only scores 4 points. And yeah, this is already like I don't remember what was the result of the last match, but anyway. So now let's swap the colors. So now we do exactly the opposite. So we'll be playing. Um, so okay, 6-4. Just remember the 6-4. Okay, so now old network is plain black and placed in the center, which is good, and the new network is plain white, represented with zeros. And I'm not quite sure what it's doing so far, but we'll have a look. Well, this move is suicide, really. Yeah, so far, black is doing fantastically well. So far, old network is crushingly winning, unless something weird is going to happen here. Probably not. Or is it? Wow, results in a draw. Well, that's rarely good, but well, in the real game of Go, there may not be draw, but uh, due to some bugs and inaccuracies, due to some bugs in. Okay, now white is doing fantastically well because it occupies the center and tries to split both vertically and horizontally. Well, it's a little bit too like over concentrated, yeah, which costed the game result. Oh, what have you done? What the first move? Oh my god! Oh, that's weird. Yeah, it's probably the first time where the engine is not playing better with white stones because so far all the iterations we've been witnessing earlier, how they play, it was performing better with white stones for some unknown reason, but now it seems like it's no longer truth, which is a bit surprising to me because I have no idea what has changed since then because I didn't really change anything. So that's the pure matter of the training process itself. And I have no idea why is that happening. Yeah, so it's crushing. Like, yeah. What? Whoa! White has managed to win, made two eyes. Amazing. That shouldn't happen, really, but it did happen. I don't yet see what's the improvement for the newer version when it plays White Stones. Feels quite dumb to me so far. Feels like doesn't make sense so far. But, well, on the other hand, Atari, whoa, whoa, whoa. Atari, another Atari. Uh, okay, takes. Okay. Okay, now the Atari. Yeah, -1. Yeah, this was really cool. Yeah, this was fine. This was nice. Yeah. Okay. It's getting more and more interesting every next time the new model arrives. So yeah, I should have uploaded the models to my GitHub where the code is hosted, so that you guys could also try this at home as an experiment. So if I'm playing this is the neural network as a human player, it doesn't make sense because you will win every single game. Well, if you're a good player, if you're a beginner, you may potentially have some interest playing with it. Maybe, maybe not. It's hard to say. Yeah, white is doing some strange thing. If it wins, I would be really surprised. But yeah, it manages to win. Such a weird way. Oh, yeah. It's I don't know why why this is the first move. This is so strange. But the 30 iterations network keeps this strategy over and over again for some unknown reason. He then recovers and plays in the center. But the first move looks like a handicap to me. Yeah, but assuming the dumbness of the opponent, even though it seems like 10 iterations more, still this strategy kind of works. It may work if not careful. And white is playing a very dangerous game, I think. Yeah. Okay. So this should win. Okay. Okay, fantastic. Oh, killed everything. Cool. Cool. So the previous match, if I'm not mistaken, we had like 6 wins versus 4. Yeah, I guess we had 6 wins, so this is 4. We can quickly check that. So if I do, yeah, we had 6 wins versus 4. Okay. Another win by white. Yeah, white splits again. It's Harry. Okay, should have taken it, Harry. No way. You should have taken. Oh, yeah, now this is lost. Now this is lost. Unless a miracle happens, but I don't believe it. I don't believe it. Whoa! That's the miracle I've been talking about. This is probably not enough for win. Oh, no way! No way! Oh, oh, this cannot happen in real life. This cannot happen in real life. Yeah, it's just because opponent is too dumb. That happened, but this shouldn't happen really. Although good for white because yeah, save the hopeless position. Yeah, that position was really hopeless. You should never be one versus the human player. Oh my god, it's trying to. Well, this time this is correct. It should have captured immediately. Yeah, but you should not take the central point like this. Probably, or maybe that's fine. Maybe that is well. That's the suicide. 0-0 and you get captured. But yeah, yeah. If opponent doesn't take your stones, that you just give up. Then yeah, this may work. Okay. New network scored 14 points, and the old network scored only 5 points. Well, okay, guys, this is it from my side. Thanks for watching, and I hope you got excited during watching these games like I did. So, next video, we are going to be playing 50 iterations version versus the 40 iteration version, and hopefully that would be as exciting as this one. And I'll see you in the next video.